So corresponding angles, the way that we actually copy an angle down to make parallel lines, that construction that we learned, that's actually copying corresponding angle. That's actually, so this is the way that we've always made these parallel lines when we did the construction, because we're copying the corresponding angle. So since we're copying the angle, we know it's going to equal the same measurement. They're going to be equal because they're congruent because we copied it. So that means that these angles right here, they are corresponding because they're in the same spot. So that's the first definition here. Corresponding angles lie in the same side of the transversal and on the same side of the intersected lines. So I like to think of it kind of like streets. If you picture these as streets, it's kind of weird because everyone's going kind of crooked. It's kind of like Grand Avenue around here. But if you picture them as streets, you have like the corresponding intersections. So you've got like the northwest corner intersection would correspond with the northwest corner of that intersection. They're in the same spot. You do the same thing with the northeast corner. Those are corresponding. You do the same thing with the southeast corners. Those are corresponding. And then the last one's obviously southwest corners. Those will be corresponding angles. So you get different sets of corresponding angles. You get 4 corresponding angles because there's 4 angles in the top intersection and 4 angles in the bottom intersection. And if you match them up the way that I color coded them, those are corresponding angles. They're on the same side of the transversal and the same side. So it's like northwest and northwest, just like we talked about. So we're going to go through a proof to show that angle 6 and angle 8, which are corresponding angles. We're going to prove that corresponding angles are the same. They are congruent. So every single proof, we've talked about this with other proofs that we've done. The very, very first thing you write when you do a proof is the given. So we are given the 2 lines are parallel. P is parallel to Q. Always start with the given. So once you've got the given, you look at the picture and you try to remember from all of the geometry that you know, what's something that we could apply here. So we know a lot of stuff. We know vertical angles are congruent. We know linear pairs always add to 180. And we also know that same side interior angles are supplementary. So we can use any of that. Vertical angles are congruent, linear pairs are supplementary, same side interiors are supplementary. So we're going to use, this is where the art comes in. We're trying to tie angle 6 and angle 8. So we need to make sure that we use one of those angles, either 6 or 8. So 6 and 7 are supplementary because they are same side interior. Now we want to tie that also to angle 8. So we can also say that 7 and 8 are supplementary because linear pair. So now we just have to make equations so that we can do some algebra with this. We can make an equation, 2 equations actually, because supplementary means they add to 180 degrees. So if 6 and 7 are supplementary, that means angle 6 plus angle 7 equals 180, and angle 7 plus angle 8 equals 180, because that's the definition of supplementary angles. We've done proofs really similar to this because we've got two angles add to 180, two different angles add to 180. But since they both equal 180, that means they equal each other. So we're going to substitute, or you could actually say transitive property also. Because if two things are both equal to 180, that means those things are equal to each other. So 6 and 7 equals 180. We can substitute out that 180 with 7 plus 8 because it's also equal to 180. So that's substitution, or you could say transitive property. That's okay too. That'd be appropriate. Either one would be fine. So now we've got one algebra equation that we can solve pretty easily. Because remember, we're trying to get 6 and 8 to show that they are congruent. That's our goal for the whole thing. So if we can get 6 and 8 to be the only things in that equation, we're in a good spot. And that's pretty easy because all we got to do then is get rid of angle 7 on both sides. And you're allowed to do that by subtraction. Subtract angle 7 from both sides. The subtraction property of equality. And then our last statement, we weren't trying to show that the measures were equal. The actual phrasing at the very top of this proof is prove that they are congruent. Congruent means they have all the same measures, which we just said they have the same measures. So that means they are congruent because that's the definition of congruent. Same measure means they're congruent. So every single proof will always start with the given. Then you need to look at the picture and see what other information you can get from that picture. So we could use same side interior, linear pair, vertical angles, all that stuff that you know. What else do you know from that picture? And then the art is tying it together so you can end up saying the statement that we needed to say. Angle 6 congruent to angle 8. So we just proved it. We talked about it earlier. But if two parallel lines are cut by a transversal, so if the lines are parallel, remember that's the marking. You put an arrowhead in the middle of the lines. Corresponding angles are congruent. And it's pretty obvious, in my opinion. Number one, we know it because that's how we make parallel lines. We copy a corresponding angle down to where it is. If it's a copy, that means it's congruent. But additionally, you can just look at the intersection. And then if you translate it, obviously everything matches up. So you can see that all four corners are corresponding, and you can do a translation to show it, to show that they're going to be congruent. Translate the intersection down to the other intersection, you can see that they all match up and they are all congruent. So these two angles are drawn out. The lines are parallel. We're told they're parallel. The lines are parallel. So that means that we've got those angle relationships. So these angles right here, those are corresponding in their positions, which means they are congruent. They're equal to each other. Since they're corresponding, that means they are equal. So x minus 4 equals a fraction. So we're trying to solve this out. Anytime you have an equation with fractions, or at least anytime I have an equation with fractions, the first thing I do is get rid of the fraction. So to get rid of a fraction, you just multiply by the common denominator through everything. So the denominator here is 6. Multiply everything by 6. 6 times x, 6 times negative 4, and 5 minus 6, or 5 over 6 x times 6. Every single term gets multiplied by a 6. 6x minus 24 equals 30 divided by 6 is back to 5. Or you could have just canceled. That's the easier way. 5x. Now get your x's together and solve it out. So now we're trying to get everything together to solve it out. So let's move the 6x over. We have negative 24 equals negative 1x. And we don't want a negative x. We can change those signs. Divide by negative 1. X equals 24. And always in geometry in particular, always go back and make sure you answered the question correctly. Because it might be asking what's the value of x, or it might be asking what's the measurement of the angles. In this case, what's the value of x? That's it. We don't need to plug it back in. X is 24. But half the time it'll ask for x, half the time it'll ask for the measure of the angle, where you'd have to plug it back in. So another type of angle relationship is alternate interior angles. So you can do the same thing. If you've got parallel lines cut by a transversal, which the construction will create parallel lines with transversal. So alternate interior angles. Alternate means you have one on each side of the transversal, and interior means between the two parallel lines. So there's your two parallel lines. We're looking at the interior, which would be all of this. That's all the interior. Alternate is the opposite of same side. We already talked about same side interior. Alternate would be the opposite of that. It would be on the opposite side. So like those two yellow highlighted angles. Or these two green highlighted angles. Those are alternate. You got one on each side. But they're both between the parallel lines. Those are alternate interior angles. They're not next to each other. They're non-adjacent. And they're on opposite sides of the transversal. And they are between the intersecting lines, or the intersected lines. So now we're going to talk about those angles in a proof. We're going to see relationship between them. So every single proof, you always start with the given. P is parallel to Q, given. And then there's lots of options. There's more than one way, more than one correct way to do a proof. Because our next step is always just looking for relationships in the picture that you know. So now we know lots of stuff. We know corresponding angles are congruent. We know same side interior angles are supplementary. We know vertical angles are congruent. We know linear pairs are supplementary. So we're going to try to tie 3 and 7. So if we're trying to tie 3 and 7 together, we need a relationship that's going to one other angle that can tie to both of them. And like I said, there's more than one answer. So we're going to go ahead and use angle 5 to tie them together. So if we choose angle 5, there's other ways you could have done it. You could use angle 2. You could also use angle 6. All of that would work. But we're going to choose angle 5 right now. They can both be tied together with angle 5. So ask yourself, how can 3 and 5 be tied together? How can 7 and 5 be tied together? 3 and 5 are vertical angles, which means they're congruent to each other. 7 and 5 are corresponding angles, which means they can be congruent to each other. They can be tied together. So first, 3 and 5. Vertical angles, which means they are congruent. And then there's 7 and 5, like we said, which are corresponding. They're both in the bottom right. They're both in the southeast corner of the intersection. So 5 and 7 are corresponding, so they are congruent. And now we tied them together. We tied them together with 5. 3 is congruent to 5. 5 is congruent to 7. So we're pretty much done. One more step, actually. So since they're both congruent to angle 5, that's the transitive property that tells us that they're going to be congruent to each other. When you eliminate the middleman, when you eliminate the 5 in the middle. 3 goes to 5, 5 goes to 7, so you can just eliminate the 5 in the middle. 3 goes with 7. Which was the statement we were trying to prove. 3 is congruent to 7. So we're done. So you're always going to start with the given. You're going to use the picture to get more information. But when you use that picture, you need hopefully just one angle that can tie the two that you're trying to talk about. So we were trying to relate 3 and 7. We needed one angle that could have worked. So we chose 5. You could have chose 6. Then you could have said 3 and 6 is a linear pair, which means they add to 180. And then you could have chose 7 and 6 and said that those are same side interior, so they add to 180. And then since they both add to 180, they equal each other. Subtract angle 6 from both sides, and you got the same answer. So that proof that we just did, that's the proof of the alternate interior angle theorem. If two lines are parallel and cut by a transversal, then all of their alternate interior angles are congruent to each other. So those angles will be congruent because they are alternate interior angles. Let's go ahead and number them instead. So alternate interior angles, like 4 and 6. Angle 4 is congruent to angle 6 because they are alternate interior angles. And then likewise, angle 3 is congruent to angle 5 because they are alternate interior angles. Now, my favorite part about alternate interior angles is actually, maybe a little bit vain of me, but they're my favorite angle because when you trace them out, when you trace out angle 4 and angle 6, it makes a Z. So, like destiny. So alternate interior angles always make a Z. When you trace out the two angles at the same time, it makes a Z. Sometimes it's a little bit weird, but sometimes like 3 and 5, those are also alternate interior angles. It's kind of a weird looking backwards Z, but I'll still take it. If you use your imagination, it's still a Z. So we're going to take these two angles. So we're looking at these two angles. If you have a hard time figuring out what they are, try tracing them. And that's one of those obscure Z's. So they are alternate interior. They are alternate interior, which means they are congruent or equal to each other. So 3 over 4x plus 80 equals 2x plus 10. Then we've got another pesky fraction. So our denominator is 4. We want to get rid of denominators. So you're going to multiply every single term times 4. Every term. So when you multiply a fraction with a 4 on the bottom times 4, they just cancel out. So you get 3x. 4 times 80. I know 4 times 8 is 32. So you just got to tack a 0 on there. Four times 2 is 8x. And then 4 times 10 is 40. So now get all your x's together in this equation, not in real life. I'm not sure. So 8x minus 3x is 5x. And then we also got to subtract that 40 over using the subtraction property of equality. Minus 40 minus 40. So we have 5x equals 280. Divide by 5. You get 56. Maybe you need to pull out a calculator for it, maybe you don't, but the answer is 56. So with every geometry problem like this, always go up and make sure you answered the right question. Value of x. It didn't say what's the measure of the angle, it said the value of x. So we're done. If it did say value of or the measure of the angle, you just got to plug it back in.